Now that we can write balanced equations for acid-base reactions, we need to be able to determine if they're extensive. In redox, we computed a potential for a reaction, and we used its sign to tell. While it's possible to compute an equilibrium constant for an acid-base reaction, we'll simply use the position of the acid and the base on the acid-base chart to determine extensiveness. In the previous video, we wrote balanced net equations for 3 reactions. Let's now determine if they are extensive. Is the reaction between aqueous solutions of HF and sodium cyanide extensive? We wrote this balanced equation. It's worth noting the conjugate pairs in this equation. HF is an acid, fluoride is the conjugate base. Cyanide is a base, HCN is the conjugate acid. There is an acid and a base on each side, and we're going to determine extensiveness using their relative strengths. We've drawn a rectangle around the 4 components of this reaction. Simply based on location, HF is the stronger of the 2 acids. Neither of them is strong in the way we've defined strong and weak acids, but remember that acids get weaker as you go down, so HF is the stronger of the 2. Again, based on location, cyanide is the stronger of the 2 bases, since bases get stronger as you go down. Let's go back to the equation and insert our relative strengths. We said HF is the stronger of the 2 acids, and cyanide is the stronger of the 2 bases. Now, what do you suppose makes a better reaction? Strong reactants or weak reactants? Well, of course, stronger ones will react better. The strong reactants make a good reaction going in the forward direction. The weak products don't make for a very good reverse reaction, so in this case we end up with mostly products, which is the result of what we called an extensive reaction. This leads us to a rule of thumb. Acid-base reactions will always end up on the weaker side. In this case, the product side is the weaker side. This reaction ends up mostly products. It is extensive. Our next example asks, is the reaction between NaHSO3 and phosphoric acid extensive? The first thing we need to do is to write a balanced equation, which we have done previously. In this case, the hydrogen on phosphoric acid is the one that is transferred. So phosphoric acid is the acid on the reactant side, and its conjugate is the base on the product side. Hydrogen sulfite is the base on the reactant side, and its conjugate is the acid on the product side. Let's consult the acid-base chart for the strengths. Again, we've drawn a rectangle around the 4 components of this reaction. On the acid side, sulfurous acid is the stronger of the 2 acids. On the base side, dihydrogen phosphate ion is the stronger of the 2 bases. Now we go back to our reaction and put in this information. Between the 2 acids, we determined that the product acid is the stronger one. Between the bases, the product base is the stronger one. By the way, it should always work out that the 2 stronger components will be on one side, the 2 weaker components on the other. Since acid-base reactions always end up on the weaker side and the reactants are weaker, this reaction is not extensive. Again, the reactants are poor at reacting, while the products, if formed, are very good at going back. Since this reaction starts on the weaker side, it's happy where it is. Our last example asks if the reaction between perchloric acid and potassium hydrogen sulfide is extensive. We use the balanced equation we used previously. Again, we assign acids and bases, noting the 2 conjugate pairs. Going to the acid-base chart one more time, we put a rectangle around the reaction components. On the acid side, hydronium is the stronger of the 2 acids. On the base side, hydrogen sulfide ion is the stronger of the 2 bases. We go back and assign the comparative strengths of the 2 acids and the 2 bases. Noting that the weaker side is the product side, this reaction should end up mostly products, which makes it an extensive reaction. To use this simple rule of thumb, you should see that we need to identify the acid and base in both the reactants and the products. We also have to be able to navigate the acid-base chart. Be sure to work some examples so you become comfortable with this.